Hello students, and in today's class we are going to talk about the gaseous state. In the gaseous state lesson, what is the objective of learning this lesson? The main objective to understand the properties of the gases. In the atmosphere, we have got plenty of gaseous substances, namely the nitrogen, oxygen, chlorine, ozone, helium, neon, krypton, xenon, variety of gases, but the percentage of existence differs from each other. And apart from these gases, we have got some compounds also in the form of gases, namely carbon monoxide, carbon dioxide, and nitrogen dioxide, and other oxides of nitrogen, and some oxides of sulfur, etc., are present. So, for all these gases, the properties are to be studied and certain phenomena which are related with these gases, related phenomena. So this is the main objective of learning this lesson called gaseous state. Regarding this lesson, the first and important point, you should know the meaning of pressure. What is called a pressure? Generally, the pressure is defined as force by area. We know the unit of force. The force is either expressed in the Newton, otherwise it can be given in kilogram, meter, second power minus 2, and the area is to be noted in meter square. So the unit of pressure will be Newton meter power minus 2, otherwise we can have kilogram, meter power minus 1, and second power minus 2, because this meter is cancelled with this meter square. So this is the unit of pressure. And the other units of pressure, apart from the Newton meter power minus 2, what are all the other units? Commonly they are using Pascal. A Pascal can be represented by PA. This PA, 1 Pascal, that is equal to 1 Newton meter power minus 2. And other unit to represent the pressure will be atmospheric unit, atmosphere. It is to be noted as ATM. And 1 ATM, that is equal to 101,325 pascals. This much of pascals are equal to 1 atmosphere. Likewise, millimeter of mercury, that is the other unit, that can be given as mmHg. 1 mmHg, that is equal to, we can say, 133.322 pascals. And the other will be the bar unit. It is to be expressed or given as bar. 1 bar, that is equal to 10 power 5 pascals. So these are all related with the Pascal. And tar, other one will be the tar, expressed as T capital OOR. This is a representation of the tar, and 1 tar will be equal to 133.322 pascals. It clearly shows that mercury as well as tar are equal to each other based on this relationship. And other unit will be the pound per square inch, and this is given as PSI. Most commonly for the checking of air in the tires of our two-wheeler, four-wheeler, motorcycle tires, in which they are using this particular PSI, pound per square inch. 1 PSI, that is equal to 6894.76 pascals. So just know the relationship in between the Pascal and Newton meter power minus 2. And this is a data will give the clear-cut idea about the various units of pascals and how are they related with each other. And we are going to discuss about the Boyle's law. Boyle's law, which is nothing but pressure volume relationship. Yes, you just see the diagram what is given here to understand this Boyle's law. In the first tube, one of the end is closed well and other one is opened. Now certain amount of mercury is filled here. While adding the mercury, the levels are equivalent or equal in both the limbs, and this is the area which is occupied by the air which is inside the tube. So the volume of air, otherwise the volume of gas, is considered as V. V is the volume of air which is present inside the tube. Now in our subsequent attempt, we are going to add some extra amount of mercury to this tube. We are going to add the mercury from the top. So when you add the mercury, actually the mercury level goes up and level of air, the volume of air is getting contracted. It is decreasing up to V by 2. Original volume is V, now it is getting reduced up to V by 2. Now you see the levels of mercury is not equivalent now in both the limbs. In this particular side, in the left hand side, this is the original level of the mercury, and in the right hand side limb in which the mercury level is up to this. So this mercury level height difference is equal to, it is measured as 760 mm. Now here there is no difference in between the mercury level, and hence the pressure is actually noted as 1 atm. 1 atm pressure in the first case. Now there is a pressure difference. We are increasing the amount of mercury, so the level is differing up to 760, and we can say that now the pressure inside the tube is 2 atmosphere. It is getting doubled. So when the pressure is doubled, the volume is getting 50%, half of the original volume. It clearly shows that when the pressure increases, volume is decreasing. So that's a law called Boyle's law. Just see the another trial or in other attempt. Some more amount of mercury is filled here from the top. So the original volume of air is V. Now it is getting lowered up to V by 3. So again, in addition to 760 mm of mercury is now newly added. So originally 1 atmosphere in the first tube, in the second tube it is 2 atmosphere, now it is getting converted into 3 atmosphere because the mercury height is 1520, 760 plus 760. And original volume is V. In the second tube it is V by 2. In the third tube it is V by 3. It indicates that pressure and volume are inversely proportional to each other at a fixed temperature of T. So these are the three quantities we should consider: pressure, volume, temperature. The Boyle's law says that at constant temperature, when the temperature is not varying, volume of the gas is inversely proportional to pressure at constant temperature. So it's very easy to understand this particular case. We can able to write V, that is equal to K into 1 by V, where K is nothing but proportionality constant. And we can say PV, that is equal to K. Otherwise we can say PV, that is equal to constant. So this is the mathematical expression of Boyle's law. Consider the gas in the pressure of P1, its volume is V1. The same gas in other pressure P2, its volume is V2. So are two different conditions, more than one condition. The relationship can be noted as follows: P1 V1, that is equal to P2 V2, that is equal to K, that is equal to constant. This can be given in the graph as follows. Graphical representation is possible. Yes, in this particular graph, if you see in the x-axis, we will be taking 1 by volume in the unit of decimeter cube. Likewise, in the y-axis, we should take pressure in the atmospheric unit. And we know that the pressure and volume are inversely proportional to each other. When 1 by V increases, try to understand, it is not V. 1 by V increases means P will also increase, so that you can have a straight line like this. We are relating the pressure and volume. Pressure is taken in the y-axis and 1 by V is taken in x-axis. For every rise in 1 by V, the pressure value steadily increases so that you can have a straight line. This is a graphical representation of Boyle's law. Similarly, instead of plotting like this, when you take the PV diagram, which means the pressure is taken in the x-axis and volume is taken in the y-axis. When the pressure is lesser, you just see this is a 0 or 1 atmosphere or lesser than that, the volume might be greater. For every increase in pressure, there is a gradual decrease in volume. This is clearly indicating the relationship in between the pressure and volume. They are inversely proportional to each other at a constant temperature. And what are all the consequences of Boyle's law? The consequences of Boyle's law can be explained as follows. And we will discuss that P1 V1, that is equal to P2 V2. And we know what is called density. Density is nothing but mass by volume. So I can say that the density is given as D, that is equal to M by V. When the volumes are differing, if volume is V1, correspondingly the density is to be taken as P1. Similarly, if volume is V2, the corresponding density is to be taken as D2. Sorry, this is D1 and this one is D2. The density is D1 and D2. So I am calculating D1 that is equal to M by V1 and D2 that is equal to M by V2. According to this, what is V1? V1 is M by D1 and V2 is M by D2. Try to understand. So this can be taken as equation number 1. P1 V1 that is equal to P2 V2. And this is to be taken as equation number 2. And this is to be taken as equation number 3. Now substitute equation 2 and 3 in equation number 1. Then what will you get? P1 into M by D1 that is equal to P2 into M by D2. We know the mass is fixed for the gas. So it gets cancelled from both sides. So we can have a relationship as follows. P1 by D1 that is equal to P2 by D2. This relationship shows that the density of the gas P1 is directly proportional to D1, P2 is directly proportional to D2. Greater the density, greater would be the pressure. Consider a vessel like this in which these are all the gaseous molecule means here its density is greater. So due to the greater density, the pressure of this gas is also greater. Greater the number of particles and hence the density increases. When there is an increase in density, pressure will also increase. This is the consequence of Boyle's law. Is it clear? And likewise, we have to talk about the other law called Charles' law.